engineers developed new software tools to aid material modeling research. A new software tool can accelerate material science research by cutting out tedious background research on material properties. Penn State and Sandia National Laboratories researchers recently debuted PromSim, an open-source software on the programming platform MATLAB, to calculate the fundamental constants needed to describe the physical properties of solids such as metals, ceramics, or composites. Researchers input a material physics characteristic and structure, and the program produces its fundamental property constant, key values research need to model various materials. Some physics models contain hundreds or thousands of redundant components, which can make the model overwhelming, said Anubhav Roy, a doctoral student in engineering science and mechanics in the Penn State College of Engineering and first author on the paper. The program is able to greatly reduce the number of components for any physical property that is connected to solid with inherent crystalline symmetry. The research developed PromSim, the details of which were published in the Journal of Applied Crystallography, after they could not find reliable information about LANXESS, a material used in sensing and energy harvesting device, and a separate joint study with Sandia National Labs. Traditionally, the relationship between fundamental constant and material symmetries are found only in appendices of textbook or table in journal article. Cube and his collaborator used PromSim to determine the properties of langousite, such as elasticity and the ability to accumulate electric charge. But Cube emphasizes the program is not limited to those two properties alone. The software is adaptable to nearly any physical property of interest. The possibilities really are endless, Cube said. Ultimately, I hope PromSim helps to lower the entry barrier for analytical modeling of complex physical behavior. A lot of modern problems in the science often are demanded too challenging for analytical models without serious consideration of an analytical approach.